Okay, hello class. In this lesson we're going to learn how to solve nonlinear systems. Remember, a system of equations is basically multiple equations, and we need to find the solutions that solve each one of the equations simultaneously. We're going to solve equations by graphing as well as algebraically. Now, let's just start by talking about this. Remember when we had something like 3x plus y is equal to 6, 2x plus 3y is equal to 11. We had different ways of solving this. We can graph this, and if we graph it, we might get something like this, and, I don't know, something like that. And where they intersect, we have a solution. We might use substitution, where we solve for y and then plug that into this other equation. We might use elimination, where we, multiply this equation here by -3. We get a -3y. When we add these up together, we eliminate the y variable. We could then solve for x. So we had those different ways of dealing with linear systems. Now, today, we're going to deal with nonlinear systems. Nonlinear system just means a system of equations, multiple equations, where one of them might not be a line. So, like in this case here, these are both parabolas. In this case here, we do have a line, but this other one here is actually not even a parabola. It's an ellipse. We haven't talked about that, but we could solve this now as well. So we're going to look at how we can solve these kind of equations. The nice thing is, exactly the same methods. We can graph to solve, we can substitute to solve, we can eliminate to solve. So we're going to look at all three of these methods next. Let's take a system like this. If we have a nice tool like Desmos or a calculator, we could graph it. If we were to graph each equation, we'll get something like this. So we have this equation here, which is in blue. We have this other equation here, which is in orange right here. And where they intersect is the yellow. These are all different xy points that satisfy this yellow equation. These are all the different xy points that satisfy this orange equation. So these two specific points at the point of intersection are the two unique points which solve both of these two equations. Now, if we graph things out, we might have a case like this where we have a parabola and a line. We have two solutions in this case. Maybe we have one solution if the line just intersects or is just tangent to the parabola. Or we might have no solution. They don't touch at all. Same thing with parabolas. We have cases where we have two solutions, 2 points of intersection. One solution, 1 point of intersection. No solution, no points of intersection. Now, graphing is kind of a limited way. It works well when we do have a tool. It's a great way, actually, when we have a tool. Wonderful way. But sometimes we don't. And so if we just want to graph it by hand, we're going to get very imprecise answers by graphing. So let's look at some algebraic methods. First off is substitution. So I'm going to solve for y. I can take either equation and solve for y, but I'm going to solve for y with this second equation. And then what I'm going to do is then plug this into the first equation. So, I took the first equation, 2x squared minus y, but instead of y, I'm going to substitute it in right here. So now I got rid of the y. And now I have a single variable, and I have a quadratic equation, and I can solve any quadratic equation. In this case, We're going to solve it with square roots because I have a nice singular x squared term. So I have x squared is equal to 5/3. Take the square root of it. Don't forget the plus or minus. And we have part of our solution. But we're not just solving for x. We want to solve for y as well. So we need to take this solution and plug it back into one of these solutions here. So when we do that, we find out that y is equal to -2/3, and we have our solution. And so I should actually write it like this. One of my solutions is 1.3 comma -0.67. My other solution is -1.3 comma -0.67. So those are my two coordinate points, my two xy pairs that are my solutions. Okay, let's do the same thing, but now solve it by elimination. Now, in this case, this is just set up nicely to eliminate. If I just add, the y's will be eliminated. So we'll do that. We get 3x squared is equal to 5. X squared is 5/3, which is exactly what we saw previously. It's the same system, so we should expect the same answer. And so we get to this point, and I'm not even going to show, plugging it back in because it's the same system as before. I just wanted to kind of demonstrate how, in some cases, substitution is really the straightforward way of doing it. In other cases, we can do it by elimination. Doesn't matter, both will work. Okay, so I have some problems here. Just try each one of these out. 6 problems. I'll show these in 3, 2, 1. I want to talk about this one right here for a moment. If you eliminated this right here, you might have gotten to this point here. Do not divide away the x, instead factor it out. This will generate two solutions. We kind of have a times b equals 0. Either a is 0 or b is 0. So we have two solutions. X is equal to 0, x is equal to -4/3. So actually we need to solve for y as well, and we get these two solutions. So if you divided away the x value right here, you would lose this whole solution right there. Okay, 3, 2, 1. Okay, that's it for today. Have a good day.